for closed bodies, but you can literally sweep things along here and recreate the part. So the end result is you'll have something that looks like this. It's got kind of all of the mesh in it, and you'll have this part that is pretty, I mean, I'm not expecting you guys to like draw lines from node to node on this thing, because your final part is going to look all bumpy and gross like these IGES parts are. You're trying to recreate a part that is actually manufacturable and looks nice, but you're pretty much trying to get it so that the geometry is very close to what the IGES is. Okay? So once you've got that, you'll turn off the IGES and you'll show the final part, and that's how you can get this final part, okay? So that's all we expect for the in-class exercise. When you guys are recreating these parts for your actual homework, you'll need to make sure that all of these sketches that you create are relative to your skeleton. So you'll need to make sure that they're parameterized and that they're linked up to your skeleton, so that when you hit in the IGES file, you can morph the recreated part and still have it fit. There's a couple of images in here that I wanted to show you guys.
The pictures of the...
Yeah.
Okay. Yeah, and with that, it's more important to spend more time on your part and not the tutorial part. Like, don't spend tons and tons of time making the tutorial part look really good.
Yeah.
Like, I can't make one, but don't worry about it too much.
I got a question. For this homework, do we all have to do the control arm?
Yes. Individually, you mean?
Yeah. Because
Yes.
that just seems like a waste of time to me.
Because they're doing like one that they're actually going to
Yeah.
do.
But we're not doing a part that we're actually going to do for the final project.
Yes, that makes sense. But the purpose of this lab is to still not just do the tutorial, but to do one. And then you could use one of those as in the project, and then still do another. So
Just because like the people that are doing suspension are already doing this.
I said it does make sense, but however it is this assignment. So
Yeah.
So let's do it.
So this will be your first screenshot. You'll have the IGES component with the part. That'll be your in-class assignment.
yeah, if you have the lab printout, look, this is really clear. These pictures are exactly what you turn in. 1, 2, 3, A, 3B, 4, 5, 6C, 6B.
Yeah. So for the first one where it says you'll need one image that is normal size with the or your optimized IGES car with the Catia part model, that's this one right here. So you'll have an IGES with the car part. Then you'll have a screenshot of just the optimized cart without the IGES. Okay. And then you're going to take an actual part from your car, so something that's already in there. You will run an off-destruct analysis. Well, first of all, you'll show that it's parametric, right? So you'll show that you can move it. You'll come into off-destruct, and you'll run an analysis, and your analysis, you'll have a screenshot of the eaten away geometry. You'll then bring that back into Catia. You'll recreate the part and show the part with the IGES geometry in it. Then you'll have just the regular part without the IGES. And then you're going to show that that new part can be parametrically changed. Okay? So that's kind of what we expect. So when you're inside Catia and you've got this thing imported and you've drawn all your geometry, you're going to need to make sure that that new geometry is constrained to your skeleton or using the parameters from your skeleton. Okay? So this thing will need to be constrained in such a way that it'll update. There's a whole bunch of different ways that you guys can do this part. The one way is just take multiple cross sections by creating new planes, and then at each one of those planes just using that clip tool that I showed you guys. So if we come into this sketch right here and clip it, you can see what's exactly on that plane, and you can just kind of make a nice, square or triangle or some nice rounded edges. You don't have to actually, go from point to point to point to point. I mean, we're not, that's just something that's not manufacturable. So we want a manufactured part, so this has got to be something nice. And then you can turn on your dynamic sectioning tool if you need to, and you can clip things at different planes as well. So you can clip things at that plane if you need to kind of get a better look and see how well that fits there. So this dynamic sectioning tool works outside of the sketcher. On the inside of the sketcher, you just do clip plane, and it'll clip it wherever you need to. So you guys can use all of those tools to kind of get a good idea of what the cross section looks like. My suggestion is to have multiple cross sections at different points where the geometry on the eye just changes. So, I mean, right here, it's all solid, right? It's just kind of one solid body, but if you come out here, it kind of breaks off into 4 legs. So you might want to have a couple cross sections in there to kind of create a multi-section solid that you can kind of loft through there. So that would be very helpful. Anyway, so you can recreate the part. If you're kind of not keen on using these multi-section solids, you can just do like a regular sketch. Like you could do let me grab that plane and we'll do a sketch on that. You can just do something that looks like this, even if you wanted to. Come down here. Come over here, place that, come up here, place that, right? So there's that, and then you can pad it up. Come on, pad. There you go. And you can pad it up, up to where the arrows are. Let's do like 20 and 20. So maybe more like 40. I'm not sure what the exact dimensions are on this thing. There you go, something like that, right? So you got your geometry in there, and then you can just come over here to the side and say, okay, this is kind of missing. So you could do a sketch on this plane, and you could draw a triangle about right here to, about right there maybe. Have it come down here, come back there, hop out of the sketch, pocket it out. I don't know. Maybe a little bit more than that, maybe like 200. You'll need to make sure that this is parametric, right? Okay, so something like that. You can come up here and do another sketch. You can even do it on that face if you want to, and do something like this, Yep. Right? And so, obviously this is really, really eyeballed and very poorly done. You want to make sure that it's like symmetric and that it looks decent, things like that, but you're just basically recreating the part, but with the missing geometry that OptiStruct ate away. So you're going to basically eat away your part so that it's the same part that you had previously, but now it's got those changes, so it's more lightweight, doesn't need that extra material. And then when you're done, you'll take a screenshot of this, and then you can come in here and hide this, and eventually you'll have this new part, right? So those are some different ways that you can do it. One way is you can just kind of eyeball it, do some regular sketching the way you normally would. The other way is you can use those sectioning tools, and you can kind of take cross-section cuts, and then you can use a multi-section solid to kind of sweep through those different cross-sections, okay? So if I had, are you guys familiar with the multi-section tool? Okay. For those of you who aren't, I'll do a real quick demonstration for you. So if I create a sketch on this plane, and I do a square here, and then I have another plane offset. Let's see here, grab that plane right there, create a plane. We'll do it over here, and I'll create a sketch on this new plane, and we'll kind of do like a circle, okay? You can use this tool right here called a multi-section solid, and you can grab different geometry, and then when you press OK, it'll create a loft. Sometimes it'll throw an error like I just showed you guys, where it's kind of showing that it's kind of getting twisted. So what you need to do is you need to make sure that the geometry is pretty close to what you're doing. And I'll show you kind of a better example here.
So, like, when you're doing that, can you go
Yeah, you can. Yep. So this is a better example here, and I'll kind of give you guys a better indication of how to use it.